Welcome to the world of uninterruptible power supply (UPS) systems. In a world where uninterrupted power is essential for smooth operations, UPS systems act as guardians, providing a reliable power backup and protection against power disturbances. Whether you are a business relying on critical data centers, a healthcare facility safeguarding sensitive medical equipment, or simply a homeowner seeking to protect your electronics, understanding UPS systems is crucial. In this guide, we will delve into the realm of UPS systems, exploring their purpose, types, components, and how they work, helping you make informed decisions based on your specific needs. Furthermore, we will touch upon maintenance tips and troubleshooting techniques to ensure the optimal performance of your UPS system. Join us on this journey as we unravel the inner workings of UPS systems and unlock the power of uninterrupted electrical supply. Let's dive in and discover the world of UPS systems together. An uninterruptible power supply, UPS, is a device that provides emergency backup power to electronic devices and equipment in the event of a power outage or disruption. It serves as a protection against power fluctuations, surges, and complete power failures. The UPS consists of a battery or a bank of batteries that store electrical energy, along with an inverter that converts the stored DC, direct current, power into AC, alternating current, power, which is compatible with most electronic devices. When the main power supply is functioning normally, the UPS acts as a pass-through, supplying continuous power to the connected devices while simultaneously charging the batteries. In the event of a power outage or disturbance, the UPS immediately switches to battery power to ensure a seamless transition and uninterrupted operation of the connected devices. This allows users to save their work, safely shut down equipment, or continue working without any disruption. The backup power provided by a UPS typically ranges from a few minutes to several hours, depending on the capacity of the batteries and the power load of the connected devices. UPS systems are commonly used to protect critical electronics and equipment, such as computers, servers, data centers, networking devices, telecommunications equipment, medical equipment, and other sensitive devices. They help prevent data loss, equipment damage, and downtime that can result from power disturbances, ensuring reliable and continuous operation even during power outages or voltage irregularities. UPS system consists of several key components that work together to provide uninterrupted power supply and protect connected devices. The main components of UPS system are: input power connector. This is the point where the UPS is connected to the main power supply or utility power. Battery. The battery or battery bank is a crucial component of a UPS system. It stores electrical energy in the form of direct current, DC, and provides backup power during a power outage or disruption. Charger. The charger is responsible for charging the UPS battery when the main power supply is available. It ensures that the battery remains fully charged and ready to provide backup power when needed. Inverter. The inverter is a key component of a UPS system that converts the stored DC power from the battery into alternating current, AC, power, which is compatible with most electronic devices and equipment. The inverter ensures a seamless transition from utility power to battery power during a power outage. Static switch. The static switch is an electronic switch that automatically transfers the power source from utility power to battery power or vice versa. It ensures a smooth and instantaneous switchover, minimizing any interruption in power supply during a power outage. Voltage regulation. Some UPS systems incorporate voltage regulation mechanisms to stabilize and regulate incoming voltage. These mechanisms protect connected devices from harmful voltage fluctuations, sags, or surges that can damage equipment. Bypass circuit. The bypass circuit is a feature available in some UPS systems that allows the power to bypass the UPS and directly supply the connected devices with utility power when the UPS is offline or undergoing maintenance. Control panel. The control panel or display provides information about the status of the UPS system, battery charge level, load capacity, and various system parameters. It may also allow users to configure settings and perform diagnostics. Output power outlets. The output power outlets are where the devices and equipment are connected to receive power from the UPS. These outlets are typically compatible with standard AC power plugs. These components work together to ensure a reliable power supply, protect against power disturbances, and provide backup power during power outages or disruptions. The specific configuration and features may vary depending on the type and capacity of the UPS system. There are primarily three types of UPS systems: standby UPS, offline UPS. Standby UPS systems are the most basic type of UPS. They monitor the incoming power supply and only activate the backup power when a power disruption occurs. Standby UPS systems are cost-effective and commonly used for non-critical applications where occasional power protection is sufficient. They provide basic protection against power outages but may not be as effective in protecting against voltage fluctuations or surges. Line Interactive UPS. Line Interactive UPS systems offer enhanced protection compared to standby UPS systems. They incorporate an additional feature called Automatic Voltage Regulation, AVR, to stabilize and regulate incoming voltage. Line Interactive UPS systems can correct voltage sags and surges without relying solely on the battery backup. They provide faster response time and improved protection against power fluctuations, making them suitable for small to medium-sized businesses and critical equipment. Online UPS. Double conversion UPS. Online UPS systems provide the highest level of power protection. They constantly provide backup power by converting AC power to DC power and then back to AC power using an inverter. Online UPS systems isolate connected devices from power disturbances, including power outages, voltage fluctuations, surges, and harmonic distortions. They offer seamless power transitions and deliver continuous, clean power, making them ideal for sensitive equipment, data centers, medical facilities, and industrial applications. Maintaining and troubleshooting UPS systems is important to ensure their proper functioning and reliable operation. Here are some maintenance and troubleshooting steps for UPS systems. Maintenance. Regular inspection. Perform visual inspections of the UPS system, including the battery, connections, and indicators, to check for any signs of damage, corrosion, loose connections, or leaks. Battery maintenance. Monitor battery health regularly, including checking the battery voltage, capacity, and runtime. Follow manufacturer guidelines for battery maintenance, such as performing periodic battery tests, cleaning battery terminals, and replacing batteries as needed. Environment monitoring. Ensure that the UPS system is installed in a suitable environment with proper ventilation, temperature control, and protection against dust, moisture, and excessive heat. Software updates. If the UPS system has associated software or firmware, keep it updated to ensure compatibility, bug fixes, and improved functionality. Load monitoring. Regularly monitor the load capacity of the UPS system to ensure it is not overloaded, as this can lead to reduced backup time and potential system failures. Troubleshooting. Check power connections. Verify that the UPS system is properly connected to the main power supply and the devices, equipment it is protecting. Ensure all power cables and connectors are securely plugged in. Check indicator lights. Check the UPS system's indicator lights or display panel for any error codes, warnings, or alarms. Consult the user manual or manufacturer's documentation to interpret the indicators and take appropriate action. Test bypass functionality. If the UPS system has a bypass circuit, test its functionality by switching the UPS to bypass mode and checking if the connected devices receive power directly from the utility. Battery testing. Perform battery tests to assess their condition and capacity. This can be done using built-in battery testing features or with the help of specialized battery testing equipment. Replace batteries if they are faulty or do not meet the required specifications. Power quality analysis. If the UPS system is experiencing frequent alarms or failures, consider conducting a power quality analysis to identify any underlying power issues in the facility, such as voltage fluctuations, harmonics, or electrical noise.